Hello guys, so good day. So in this section, let us talk about the Zeroth Law of Thermodynamics and temperature scales and the law of conservation of mass. So for now, let us focus muna sa the Zeroth Law of Thermodynamics. So before that, let let us have some history for this law. Okay. So, when the law of thermodynamics were originally established, there were only three in early 18th century. So, true scientists realized that another law was needed to complete the set. So, unsa man nga law? So, mao ni ang the zeroth law. So, ang mga scientists naka-realize sila nga napaday mas basic pa nga law. So, abi nila nga na ang first law of thermodynamics ang pinaka-basic. So, napaday usa. So, dayon, um, ang energy daw, so di ma himo ang energy or quantity sa energy kung di pud ma-predict ang direction sa heat or ang scale temperature. Okay? And so giname ni nila sa zeroth law of thermodynamics kay tungod aron dili ma uh, dili ma conflict sa literature sa existing literature and the problem of the sa kaning nga basic nga law. So one scientist, Ralph H. Fuller, came up with a third alternative heat that solved the dilemma. He called the new law or the zeroth law of thermodynamics. So, let us define the zeroth law of thermodynamics. Zeroth law of thermodynamics states that when two bodies are in thermal equilibrium with the third body, they are in thermal equilibrium with each other. So what do you mean thermal equilibrium? So it means that when two bodies are brought into contact with each other and separated by a barrier that is permeable to heat. So there will be no transfer of heat from one to other. So let us illustrate this for this case. So case number one, they have three objects. And these three objects have different temperature. Okay? So it means wala sila contact. There's no contact with each other, so there's no heat flow of this case. In this case number two, so in this body have contact with each other. So until the heat will travel to the hotter from the hotter body to the colder body. So until such time the ilahang temperature mo same. Okay, so there is a thermal equilibrium with each other sa kaning three object. So we can conclude that the zeroth law of thermodynamics frames an idea of temperature as indicator of thermal equilibrium. So let us have an analogy for this. So some patients have a fever. So he wants to measure his temperature by using a thermometer. So I have some question for you. So let's say gi-measure sa ato ang thermometer, the human body temperature or the body itself of the thermometer. So ang gi-measure aning sa thermometer is ang the body itself of the thermometer. So from applying the zeroth law of thermodynamics. So ang the human body in the body itself of the thermometer have a contact. So until such time magkapareha na sila og temperature. So ang girade sa thermometer which is ang body itself. So body itself of the thermometer. So ma-apply sa zeroth law of thermodynamics. So the zeroth law of thermodynamics defines temperature scale and makes thermometer possible. So dili mugna ang thermometer through sa dili pag-apply ani nga law which is ang the zeroth law of thermodynamics. So let us define the temperature scale. So temperature scales enable us to use common basis for temperature measurements, and several have been introduced throughout history. All temperature scales are based on some easily reproducible states, such as the freezing and boiling points of water, which are also called the ice point and steam point, respectively. So, what do you mean temperature scale? So, temperature scale is a measurement of the body or the hotness or the coldness of a body or calibrating the physical quantity of temperature. So one of the common use temperature scales is ang Celsius scale, Fahrenheit scale, and Kelvin scale and Fahrenheit scale. Okay. So we have the formulas for converting the temperature scales from degrees Celsius to Fahrenheit Celsius, degrees Celsius. So this formula. So Celsius or centigrade is a scale and unit of measurement. It is one of the most commonly used temperature units. So let's have a comparison between these two temperatures. Okay. So na error ani. So dapat kani siya kay Celsius. Okay. So the 0 degrees Celsius kani was defined as the freezing point of water. In the 100 degrees Celsius kani is was defined as the boiling point of water, both at a pressure of 1 standard atmosphere. Okay? And the Fahrenheit scale measured temperature. It is based on a scale proposed by physicist by Daniel Gabriel Fahrenheit. The unit this scale is the degree Fahrenheit. So kani nga unit. So kana. On this scale, water's freezing point is defined to be 32 degrees, while water's boiling point is defined to be 212 degrees Celsius. So let us derive the formula of for conversion of this between this temperature. So we need ta mag-extrapolate ani. So kani nga kuan ni unit kanila mo we have this scale. So let us interpolate this. We have 212 degrees Fahrenheit minus 32 degrees Fahrenheit, which is equals to this scale or Celsius scale. We have 100 degrees Celsius minus 0 degree Celsius. Okay. And after that, kanina pod nga uh, kanina pod nga scale or this parameter. We have T degrees Fahrenheit minus 32 degrees Fahrenheit is equals na nasa T degrees Celsius minus 0 degrees Celsius. So 212 is 180. 212 minus 32 is 180 degrees Fahrenheit. Okay. And then the T degrees Fahrenheit minus 32 degrees Fahrenheit. So this equation we have 100 degrees Celsius. This over the Celsius scale, temperature scale. So we have to cross multiply para ma-came up ta ato nga formula. So 180 degrees Fahrenheit over 100 degrees Celsius times is equals to temperature Fahrenheit minus 32. So ari na to butang. So ang 180 over 100 ma-reduce na into 9 over 5 T degrees Celsius is equals to temperature Fahrenheit minus 32, or ato ang degrees Fahrenheit is equals to 9 over 5 T temperatures or Celsius scales. So balhin plus 32. Okay. So we can prove that Fahrenheit is equals to 9 over 5 times the Celsius scales plus 32. Okay. In sa usa pod so we have cross multiply para makuha na to in terms of degrees Fahrenheit. So, in terms of degrees Fahrenheit, we have cross multiply ang 5 and divide by 9. Okay. So, 5 over 9 times temperature Fahrenheit. Five over 9. Ano mali. Unahon na to balin ang 32 degrees. So, unahon na to balin ang 32 degrees. So, we have 9 over 5 T degrees Celsius is equals to T degrees Fahrenheit minus 32. So, we have T degrees Celsius cross multiply ang 5 and divide by 9. So, T degrees Fahrenheit minus 32. We have 5 over 9. Okay. So, let us move into absolute temperature. Absolute temperature is the temperature measured from absolute zero. So, absolute zero temperature is the temperature at which all molecular motion ceases. Absolute temperature will be denoted by T or capital T. So, in terms of Rankine, so temperature Rankine is equals to temperature Fahrenheit plus 460 degrees. So, in terms of Kelvin, temperature Kelvin is equals to temperature Celsius plus 273 degrees Kelvin. So, absolute zero is the coldest possible temperature. Formally, it is the temperature at which entropy reaches its minimum value. So, what do you mean entropy? So, entropy, it is measurement of the measurement of disorder. So, kung anam disorganize ang atong molecules sa usa ka matter, so moanam sa dako ang ato ang entropy. So sa absolute temperature ni reach na into minimum value or which is zero entropy na siya, approximately zero entropy. Okay? So, ang mga physicists sa una nag-experiment sila or nagkuha sila og data ngano naka-came up og 200 degrees 73 degrees Celsius. So, ato ikuan probe. So, kani so by pressure temperature diagram nakuha nila ang behavior or tanang different gases kay mo point out or mag-intersect gyud sa data into 273 degrees Kelvin. So we have pressure and temperature. Okay. So this line 100 200 degrees Celsius 100 degrees Celsius there is 0 at point this. So let us indicate into gas A lang. So tanang and let us indicate by gas B. And this gas C. So at this point, tanang data daw at zero pressure is mo intersect daw into negative 273 degrees Celsius. Tanang different of gases. Okay. So nakuha nila through experiment, nakuha nila ang negative 273 degrees Celsius. So let us have an example for this topic. So, gani. Example number 1. Example number 1. At what point is the temperature in Fahrenheit exactly twice that in Celsius? So in this problem, we have to kanang express kaning nga statement into mathematical. So Fahrenheit exactly twice that in Celsius. So ang Fahrenheit daw nimo or degrees Fahrenheit is equals to twice to the degrees Celsius. So we have formula for this conversion of temperature. Degrees Fahrenheit is equals to uh, 9 over 5 degrees Celsius plus 32. Okay. 32 to uh, so degrees Fahrenheit is equals to twice degrees Celsius. So ato i-substitute diri sa formula. So 2 degrees Celsius is equals to 9 over 5 degrees Celsius plus 32. So 2 kani atoy move to right nga equation to the right uh, to the left day. So 2 minus 9 over 5 degrees Celsius is equals to 32. So we have 2 9 over 5 pila. Wait. So 2 minus 9 over 5 is equals to 1 over 5. 1 over 5 of is equals to 32. And then 32 times 5 is equals to ang degrees Celsius din nato is equals to 160. But ang ipangita is ang degrees Fahrenheit. So naman ta ani nga equation, ang degrees Fahrenheit nato is equals sa twice sa degrees Celsius. So degrees Fahrenheit is equals to 2 times 160 or degrees Fahrenheit is equals to 320. Okay. So another example. So convert the temperature of dry ice into negative 77 degrees Celsius into degrees Fahrenheit and Rankine. So degrees Celsius, we have formula degrees Fahrenheit is equals to 9 over 5 times degrees Celsius plus 32. And then degrees Fahrenheit is equals to 9 over 5, which is negative 77 plus 32. So degrees Fahrenheit is equals to plus 32 is equals to negative 106.6. So negative 106.6 degrees Fahrenheit. So in terms of Rankine, negative 106.6 plus 460. So we masolve na to ang iyahang absolute temperature. Negative 106.6 plus 460. We have 353.4 degrees Rankine. Okay. So another example. Convert the boiling temperature of liquid ammonia negative 28 degrees Fahrenheit into degrees Celsius and Kelvin. So the another formula for converting the temperature is degrees Celsius is equals to 5 over 9 degrees Fahrenheit minus 32. Okay. So degrees Celsius is equals to 5 over 9. We have negative 28 minus 32. So degrees Celsius is equals to 5 over 9 negative 28 minus 32. We have negative 33.33. Negative 33.33. So in terms of Kelvin, so we have degrees Kelvin is equals to degrees Celsius plus 273. So na naman tayo value sa degrees Celsius which is negative 33.3. So degrees Kelvin is equals to negative 33.33 plus 273. So degrees Kelvin is equals to negative 33.33 plus 273. So we have 239.67 degrees Kelvin. Okay. So let us move to the topic of conservation of mass. Okay. So, conservation of mass. The law of conservation of mass states that mass is indestructible for closed systems. The conservation of mass principle is implicitly used by requiring that the mass of the system remain constant during a process. So, like sa energy, the mass is indestructible. So, the mass can neither be created or destroyed. So, however, mass, or denoted by M, and energy, denoted by E, can be converted to each other according to the well-known formula proposed by Albert Einstein, which is E is equals to mc squared, where c is the speed of light in the vacuum, which c is equals to 2.99.79 times 10 to the power of 8 meter per second. So this equation suggests that the mass of a system changes when its energy changes food. So in a practical nga solving in engineering, so dili na nato i-conclude na kaning formula which is pang dinagkuay na nga energy naman ni like nuclear reactor yan na. So in this practical nga application sa engineering, so dili nato ma gamit ang equation. So sa mass and volume flow rate. So the amount of mass flowing through a cross section per unit time is called the mass flow rate and is denoted by M. So in other words, the mass flow rate is defined as rate of movement of liquid passed through a unit area. And we have volume flow rate. So the volume of the fluid flowing through a cross section per unit time is called the volume flow rate. So volume flow rate is a term that describes how much volume of liquid moves through space per unit of time. So let us illustrate for this. So we have control volume system. So this system has a flow entering the quantity of matter or the flow rate or mass flow rate, which is mass in per unit of time, which is equal to the mass out per unit of time. So in this figure, makonclude na to nga naa si conservation of mass or the conservation of mass principle. Okay? So we have mass balance force heat flow process or controlled volume system, which is summation of mass entering of the system is equal to summation of mass out of the system. So in terms of unit, we have kilogram per seconds. And mass balance for steady flow process in a single stream, we have mass in is a mass flow rate in is equals to mass flow rate out or equals to rho times a times velocity equals to rho times area times velocity. So the mass flow rate kay mag-depend it depends the density or directly proportional in kita ko ang amount sa imuhang mass flow rate. So maupod sa imuhang density. Okay? Ah, so let us derive nga ano ning ang mass flow rate na to is equals to rho times area times velocity. Okay? Ah, so so in terms relating between the mass flow rate, the density and the volume flow rate. So we have the density. So we could formulate that in terms of mass flow rate over the dot, so denoted by kana over the symbol dot over the symbol over the volume. So pwede sa ano in terms of volume flow rate ang imuhang density. So pwede na siya ma-ratio. So we have mass flow rate over the volume flow rate, which is volume flow rate is equals to area times velocity. So volume flow rate is equals to area times velocity. So mass flow rate is equals to rho. So cross multiply rho times area times velocity. Okay. So ah, so we have this illustration. Volume volume flow rate is a term that is described how much volume of liquid moves through space per unit of time. So volume flow rate is equals to area times velocity, where area is the cross-sectional area occupied by the flowing material, and v is the average velocity of flow. So v is considered. So we have this. So or how much volume per unit of time so this particular cross-sectional area. Cross-sectional area. So equation of flow rate is equals to denoted by V. Dot over V is equals to area times velocity. So for steady incompressible flow, we have summation in dot over equals to over the symbol and summation out dot over the symbol, which is the unit is per second. For single stream, so in incompressible flow for CD process, so we have area times velocity in is equals to area times velocity out, which is itong incompressible na siya. So dapat kani siya nga equation is rho times area times velocity. So kay incompressible flow man siya, so ang unsay point at in nga density is equal ra sa density at point sa out. So makancel siya sa may siya area times velocity equals in is equals to area times velocity out. So let us have an example for this. So, example number 3. A garden hose attached with a nozzle is used to fill a 20 gallons bucket. The inner diameter of the hose is 2 centimeter, reduces to 0.8 centimeter at the nozzle. If it takes 50 seconds to fill the bucket with water. So the question is, determine the volume and mass flow rate of water through the hose, and B, the average velocity of water at the nozzle exit. So sa kaninga problem, we have volume na daan sa bucket, which is 20 gallons. So volume of a bucket is equals to 20 gallons. So we can convert that into meter cube. Zero, ano, shift 8, 13. So in terms of 1 gallon, we have liters. So 20 gallon, we have 75.71 liters. And in 1 meter cube, we have 1,000 liters. So, divide mo, divide 1,000, we have 0.07571 meter cube. So, para makuha na to ang volume flow rate niya, so we have time, which is 50 per seconds. So, we can formulate by ang volume flow rate into volume over the time pod. So, makuha na to in terms of rate. So, volume flow rate is equals to volume over the time. So, volume is 0.07571 meter cube per 50 seconds is equals to 0.7571 divide 50 seconds. So we have 0.015142 meter cube per seconds. Okay. So in terms of mass flow rate, we have, di ba natay relation between density, mass flow rate, and volume flow rate. So density is equals to mass flow rate over the volume flow rate. So unsay gigamit nga uh, mass flow rate, the mass flow rate of water through the hose. So water man ang gigamit nga liquid. So atong density is equals to 1,000 kilogram per meter cube. Okay? So we have 1,000 mass flow rate over 0.015142 meter cube seconds. So mass flow rate is equals to 1000 times 0.15142. We have 151.42 kilogram per second. So sa B, the average velocity of water at the nozzle exists. Okay. Ah, so from the principle of conservation of mass, so the mass in or the inner diameter inner hose, the mass inner hose will is equal sa the nozzle or mass flow rate at the nozzle exit. So we have mass flow rate naman which is 151.42 kilogram per second. So mass flow rate is equals to rho times area times velocity. Then mass flow rate is equals to 151.42 kilogram per second is equals to 1000 kilogram per meter cube. So the area of the nozzle at exit which is 0.8 diameter which is diameter ba ni? So pi over 4 in terms of circle nga cross section 0.8. So in terms of meter na lang nato divide 100 squared times the velocity at exit. So velocity at exit it equals to 151.42 is equals to 1000 times shift pi over 4 0.8 over 100 squared alpha x for velocity. Shift solve is equals to sakto ba? Dako lagi. 0.8 pi over 4 rho area times velocity. So pi over 4. So shift solve. We have 3 12.40 meter per second. So example number 4. Two gaseous streams enter a combining tube and leave as a single mixtures. This data apply at the entrance section. So sa gas 1, we have area 1 is equals to 75 inches squared and velocity 1 is equals to 500 feet per second. And the specific volume 1, we have 10 feet cube per pound. For the other gases, we have area 2 is equals to 50 inches squared and mass flow rate 2 is equals to 16.67 pounds per seconds. And the density 2 is equals to 0.12 pound per feet cube. At exit velocity 3, we have 350 feet per seconds. And the specific volume 3, we have 7 feet cube per pound. So the question is, find the speed velocity 2 at section and B, the flow and area at the section. The flow and area at the exit section. So first, we have to illustrate kung unsay gi-state ani nga problem. So naday two gaseous stream intercombining tube in leaves as a single mixtures. So maghimo ta og illustrate ta og tube. Okay? So tube nanay branch which is mo mix into single stream. So we denote as kaning area is ang at point 1 and kaning area is at point 2. If i-mix nato, so we have single stream na and denoted as point 3. Okay. So sa A, find the speed velocity 2 at section so kani. So we have mass flow rate sa given sa at point 2 we have mass flow rate is equals to 16.67 pounds per seconds. And we have area 2 which is 50 inches squared and the row 2 is equals to 0.12 pound per feet cube. Okay. So now we have the formula of mass flow rate which is rho 2 times area 2 times the velocity 2. And the mass flow rate is equals to 6.67 pounds per seconds. And the density of point 2 which is 0.12 pounds per feet cube. So the area 2 which is 50 inches squared. So 50 inches squared. So ato i-convert into feet squared para mabalance ang tanang unit diri. So in 1 inch is we have 12 in 1 feet we have 12 inches. So 12 inches so squared pod and 1 feet squared. So cancel. So malis danaog in terms of feet squared. So we have velocity 2. So let us compute. So 16.67 equals 0.12 times 50 1. So ang 12 squared is equals to 144. So alpha x is equal, shift solve equals, we have 400 point, velocity 2 we have 400.08 feet per second. So now at B, so the flow and area at the exit section. So from the conservation of mass principle in multiple inlets, so kung unsay mass 1 plus the mass 2 is equals ra na sa mass 3. So from the word kuan indestructible, so ang mass 1 plus mass 2 is mo equals ra na at the exit section, which is ang mass 3. So mass 1 mass 3 is equals to mass 1 plus the mass 2 or mass flow rate 2. I mean mass flow rate. This is mass flow rate. So mass flow rate 3 is equals to sa atong mass flow rate 1. So wala pa. So atong kuhaon. So mass flow rate 1 is equals to rho 1, area 1, and velocity 1. So during a problem, we have specific volume. So atong specific volume is, so unsa to yung relation between specific volume and velocity? So specific volume is equals or reciprocal to the density. So mass flow rate 1 is equals to 1 over the reciprocal of specific volume, which is 10. So 10. And area 1, no. We have pounds per feet cube na. And area 1, which is 75 inches squared. 75 inches squared. And in 1 feet squared, we have 12 inches squared or 144 squared. And then the velocity of at point 1 we have 500 feet per second. So 500 feet per second. So mass flow rate 1 We have 1 over 10 times 75 times 1 over 144 times the 500 is equals to 26.042 feet per uh, pounds per seconds. 26.042 pounds per seconds. Okay. So the mass 3 is equals to 26.04 plus the mass 2, which is 16.67 pounds per seconds. So the mass flow rate 3 is equals to 26.04 plus 16.67. So we have 42.71 pounds per second. So nakuha na nato ang mass 3 by applying the conservation of mass principle. So now we have to calculate the area at point 3 or the area of the exit section. So we have the formula of mass flow rate 3 is equals to rho 3 times area 3 times velocity 3. So we have velocity 3 is equals to 350 feet per second, and specific volume 3 is equals to 7 feet cube per pounds. So sa value na to sa mass flow rate 3. So mass flow rate 3 is equals to 42.71. 42.71 pounds per seconds. So ang gihatag sa questions is ang specific volume man. So in terms na to og density ang at point 3. So 1 over 7. So 1 over 7, saan na siya? Pounds per feet cube. And then the area 3 is equals times the velocity 3, which is 350 feet per second. Okay. So let us calculate. So 42.71 alpha equals 1 over 7 times alpha x times 350 feet per second. So shift solve. So we have 0.8542 feet squared. 0 area 3 is equals to 0.8542 feet squared. So that's all. Thank you.